So we are live now. You can start.
Okay. So welcome to the day 3 data science, sorry, data analysis and visual. Right. Hello everyone, and welcome to the day 3 data analysis and visualization, where we actually from last 2 days we have been learning about how exactly the data analysis should be done, what are the use cases, where it is needed, where it is could be utilized the most. Okay, and we will be wrapping up tonight, hopefully. So let's get started. So actually, I gave you an assignment yesterday. How many of you have actually looked into it or even started doing it? I would love to actually know about it. How many? Anyone? I don't know. So you haven't. Okay. About you don't know about it. All right. Okay. So let's start with it. Then we will cut it. Okay. So the next topic with us is these are the topics that we will be covering tonight: percentiles and quantiles, interquartile range, median absolute deviation, box plot whiskers, and whatever that it is written in. Okay, so let's get started. So again, this is a simple, like I am again importing the libraries here simply, and these are the visualization toolkit libraries: matplotlib, seaborn, pandas again, data visualization, data manipulation both, and numpy is again for the calculation part, right? Then what am I doing here? Like, I am reading my data set from this particular Git gist, or Git, what do we actually call it? Like, if you actually go to this address, you will find the entire data frame there. Like, so you can directly read it from the web itself. You don't really have to download it. Okay. Then it's actually taking some time, but I have rendered it already. Okay, so and again, I am actually printing out my first 5 rows, which are not so new to you. Like, I have covered what were the sepal length, sepal width, petal length, and petal width, and what were the species that we were talking about yesterday. Like, we have like 3 species here in this data set: Setosa, versicolor, and virginica. And according to these features, sepal length, sepal width, petal length, and petal width, we are trying to determine somehow that which species belong to which iris flower. Like, if it is iris setosa, iris versicolor, or iris virginica, right? So we have seen like quite a good deal of code yesterday, like how exactly we can make a pair plot, how we can make a scatter plot, how exactly we can interpret data. We even saw like just by looking at the petal width and petal length, we can tell that if it belongs to Setosa or not, because Setosa was the most distinguishable species, right? That we actually studied yesterday, and the most overlaps that actually happened between were versicolor and virginica, right? I'm just recapping yesterday's session. So what I am doing here right now, I am just extracting the each species value. Okay. So what I'm telling to yes. Okay. So what am I writing here? Like, species is equal to Setosa. Basically, it is an equivalent operator. So wherever where I will be finding the species equal to Setosa, it will going to take those values only. Same for the versicolor and same for the virginica. Okay. And the moment I do it, I have the Setosa, versicolor, and virginica by 50 by 5, 50 by 5, and 50 by 5. 5, why do we have it here? Like the last species name. Okay, if we actually see any of these, like Setosa dot head, so you will see that species here is Setosa. Only consisting of Setosa's features like sepal length, sepal width, petal length, and petal. Okay. So now comes the part of percentiles and quantiles. It's quite easy, but it is quite powerful to understand what exactly you just by looking at just percentile and quantiles, you can literally tell what percentage of data actually falls in what range. Let me actually make you somewhat uh, mathematically intuitive. Let's do it. Say you have an array, okay, and you have an array of let's say 100 elements from x1, x2 to 100, x100. Okay, what will be the median value of this array? The median value of this array will be x50, right? So this x50 is nothing but the 50th percentile. Okay, this median value is nothing but the 50th percentile. So how exactly we can actually read it in the plain English? We can say that x50, or I can say that 50% of my data, 50% of my data is less than x50, right? That's how we actually read it. Okay, it actually makes sense. We are telling again, remember this array is a sorted array that actually consists of values of numerical values. We have here numerical values, and this is a sorted array. Okay, and when you actually going to find the median of that array, you will going to see that x50, like you will be finding that on the middle of it, right? That is how we actually calculate the median. Okay, so the moment you will find it, you can also say that this is also the 50th percentile. Okay, yes, is there anything? So that is how the 50th percentile actually stands for. You just need to count, or you just need to calculate the median. Same goes for the 25th percentile. So how exactly we can say, like for from like x1 to x50, let's say, what will be the median for x1 to x50? I'm actually slicing it in the half. Okay, and now I am saying what will be the value of x1 to x50 in terms of median? It will be x25, right? So this x25 is nothing but your 25th percentile. Sorry. Okay. And now since I have actually told you what the percentile is, these 25th, 50th, or 75 are nothing but the quantiles. These percentiles, just assume that I am putting the percentage sign here as well. So these are nothing but the quantile values as well. Okay. So how exactly we can say that percentile is nothing but equalize or equally you can literally part your data in equally 100 size, right? Say you have 100 elements in an array, you can literally part it in terms of 25, even in terms of 30 as well. Like you can say for the 35th percentile and for the 35th indexed array, I can tell that 35% of value will be going to less than this x35, right? So that is how actually percentile and quantile work hand to hand. Okay, so let's actually see that in action with the code. So this is percentiles and this is quantiles. So again, I am using here this np dot percentile. Okay, and for the Satosa petal length, I am actually inclined toward more petal lengths. We actually found that petal length seems to be more useful feature for us. Okay, So instead of actually dealing with the sepal length or sepal width, you can always do it. But since you have actually done all of that raw work, that you actually make good observations out of that, like now you know that petal length and petal width seems to be having much more precision over sepal length, sepal width. So you better use those. Okay. So now I can tell. Now I'm just calculating the percentile with the help of np dot percentile. Like we have the function in our NumPy library, and I'm saying that this is the a range. Basically, it will going to generate the value for 0 to 100, but with the step of 25, like 25, 25, 50, 75, and 100. Okay, so this will be the maximum value. So what I am saying here, let's just actually try to understand in plain English. Okay, so what is the median value here? 1.5, right? No, 0, 25. So actually, let me confirm it. No, 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 it will be like 0, 25, 50, and 75. Okay, that is how I believe NumPy actually calculates. Yeah, that is how it actually calculates, not from 25 but from 0. So how exactly np dot percentile works? It actually says 0 and 0, 25. What is actually going on my pen? 25, and then 50, and lastly 75. Okay, that's how actually the NumPy calculates the percentile. Okay, so how exactly we can say, like, what is the median value here? 1.5. And we also saw this value yesterday, right? We saw it when we actually calculate the mean, median, and variance, right? Saw it. So what I can tell from this, like, for 50th percentile, I can say that 50% of my data will be having petal length of less than 1.5 centimeter for Setosa species. Okay, getting my point here? Let me actually write it here. 50% of 50% of my data, 50% of my petal length of Setosa flower will going to have length less than what? 1.5. That's how you actually read it, and this is super useful. If you see, like, you can literally say, if you really need to make some sort of observations, like, you are damn sure, like, 50% there will be the probability that we can tell, like, this my petal length will going to be less than 1.5 centimeter. And the term that I'm using right now is probability, where we actually saw it yesterday. Can anyone tell where exactly we saw it? Can anyone tell me? Actually, open the chat box. I can't hear you properly, sir. Okay, please let me know if someone is having audio issues with me. Other than this, like, his name is student. Okay,
No,
okay,
sir, your audio is fine.
but okay, perfectly audible. Okay, okay, but I believe, like, okay, okay, thank you. So can anyone tell me, like, in the chat box, where we actually saw in terms of probability and the distribution frequency, where we saw it? Anyone tell me? Can anyone? Yes, exactly, PDF. But that was actually the distribution in terms of frequency. I believe the term that you really need to actually use here is the CDF. The CDF was telling us, right, with what probability we are having a number of data, like in a particular range, right? If you remember, PDF versus CDF graph, right? So that's where we actually also saw the probability, like the 50th percentile. So yes, other than our percentiles, we can also use CDFs for calculating our 50th percentile, or maybe like 70th, or any percentile, right? Because it goes from 0 to 100. So you can always look into the graph and tell which percentile value you are actually looking for. All right. Okay. And I hope actually I just stuck this, this chat box over my right top corner. So please let me know if it is creating any sort of hassle for you guys. Please let me know. Okay. So now, for the versicolor, I can tell like now you can actually read it. Like I have just written a simple English statement, and I highly encourage you people as well. Like these notebooks will be shared with you guys for sure. But when you are writing, when you are first of all, don't copy paste the code. Secondly, when you are actually writing the observations, please understand it and write it in your own language and in plain English, or maybe in your own native language. Maybe it's Hindi or Tamil or Telugu, any, be it any language, right? Okay. And okay, and now let's just say the 99 percentile. Why am I actually being inclined towards the 99 percentile? Let's just take an example. Say actually it is totally unrelated to this one, like for the iris setosa, iris versicolor, and iris virginica. It's totally, just totally unrelated, but it will going to give you a good amount of intuition, like how exactly percentiles and quantiles are powerful. Say you are working in e-commerce company, say for Flipkart or an Amazon. Okay. Okay, so now what you can say, you have the array values. Array values of what? Let's say you have around like 100 elements, sorry, 100 products. That needs to be delivered in next say 1,000 days, right? Let's say for thousand days. We are just having the array is equals to length of 1,000, all right? So what I can tell, let's say first was delivered on in 1 day itself. Okay. Second was delivered in 2 days. Okay. Third was delivered in, let's say, 2 days and 6 hours. So on and so forth. Okay. And I actually maximum that I can tell, and okay, maximum I can tell like 4.9, and last value, sorry, I actually ran out of the space. Last value is 6. Okay. So whatever actually going to be 99 percentile, you can actually calculate. Let's say not 1,000 layer, but only 100. Okay, only 100, because it will be much more feasible to actually visualize this. Okay, make a good intuition out of it. Okay, let's say I want to actually calculate the 99 percentile of it. So what will be the value of the 99 percentile? 4.9. Okay, so you can damn sure that 99% of the times my the order that I actually placed, be it from Flipkart, be it for Amazon, got placed in less than or equal to 4.9 days, right? That's how actually can make most sense out of the percentiles. Okay. Okay. And the quantiles is nothing but the ranges, like for the 25th, that we actually saw, like 25th and 50th and 75, right? And 100, obviously. All right. Okay. Okay. So that's how actually the percentile can actually take a good amount, like can actually give you a good amount of intuition about how exactly and what exactly is happening in the data. And yeah, you can create a good observations out of it as well, like the way I did here. Like 50% of my petal length of Satosa flower will going to have length less than 1.5. And you can, and I am again going to tell you, like the way I actually wrote it here, you should again, this notebook again, I'm telling you, will be going to share with you guys. Okay. So try to write your own observations here, right? Okay. So you can write like 99%, like 99% of the Satosa flowers will be going to have the petal length of less than 1.9 centimeter. Okay. So whenever someone says like I have around like say for array 1.8, 2.1, 2.1, 2.1, and 1. So you can actually tell that this data actually seems to be fishy. Why? Because you saw like from the 60% of the times you saw that the data were like 2 centimeter, 2 centimeter, 2 centimeter for the setosa. Okay, so now, but you had the idea of like 1.9, but so it has to be less than 1.9 because you had your observations here, and it can't be wrong because these are the plain observations that you are calculating, and math can never wrong unless you make some sort of error. Human errors will be there, but if you have actually plugged in every formula and every calculation right, then it can't be wrong. Yeah, it's quite ironic, right? And the next thing is IQR. IQR, it's just a fancy thing for like, let me actually make you understand. Uh, if you actually just recall just and the thing that I actually told you, like 25th, 25th, 50 and 50th and 75, right? So we can actually label those percentile as Q1, Q2, and Q3. Okay, so IQR is nothing but Q3 minus Q1. That's it. And can anyone tell me what exactly the Q3 minus Q1 will going to, what this calculation will going to give us? Can anyone actually in the chat box tell me what exactly this 75th percentile minus 25th percentile? Okay. So what actually, so actually we calculate like 75 minus 25, what it is 50, right? So we can be damn sure that 50% of my data will going to lie in this range. Yes, exactly, interquartile range. Okay, so this is the interquartile range. Like the difference between the third quartile, which is 75, and the first quartile, which is the 25th percentile. Yeah, 50% data lies in it. Yeah, sure, you're right. Okay, so this is the IQR, and I'm actually calculating how. I'm again using the NP dot percentile, Satosa's length, and calculating 75th percentile for it, and subtracting it from the 25th percentile. So please share the notebooks with us. Sure, I will. Please tell me if you have gotten the notebooks or not. Yesterday, we didn't receive any of it. Okay.
Sir, they will be posted in the community in before the session ends, all the notebooks.
Okay, okay, but because I actually, gave an assignment in it as well, so I thought I will be taking questions on it.
Okay.
Next thing is the mean absolute deviation, right? Sorry, median absolute deviation. So, how exactly you people remember the standard deviation? Like, you do realize it, what exactly it is, right? So, the first thing, how do you calculate the standard deviation? How do you calculate it? We say that x minus, yeah, square root of variance, x minus mu whole square divided by number of values that we have, square root, right? That we say the standard deviation. Okay, that's how we actually calculate it. Okay, so what exactly it is? We are just taking the average from each. We are taking the average from each average value of a data set. Like if we have like array of 5 values, so what I'm going to tell you guys that you need to calculate the mu of it, like the mean of it. Okay, and after calculating the mean, you will going to reduce it from every element, from x minus mean value x1. Like if there is x1, then there will be x1 minus mu. Okay, then x2 minus mu, x3 minus mu. This will going to be added to each other. Okay, and then we're going to divide it with the n, right? So that's how we actually calculate our standard deviation, or what exactly our standard deviation tells us. Like, let's say you have this with us, okay, and we actually found our mu value here. Okay. So standard deviation can tell with what value our mean can vary, right? If it is going to be, let's say, standard deviation can be, let's say we actually denote the standard deviation as sigma, right? And we have mu as mean. So exactly we can tell like the standard deviation. So there is a Gaussian curve. Don't worry, just stick to me, like just stick to it right now. But to actually give you a hint, like we actually saw it PDF, right? If you remember, guys, PDF, bell curve. So if mean is equals to median is equals to mode, then we can go with standard deviation. Of course we can, but the chances of happening that is quite similar, like really low. Okay, you can go with it, but the moment you will going to actually, if it is mean is equals to median, but the moment an outlier, let's say outlier used to be the human errors. Okay, so let's say when you are actually having the array of 1, 2, uh, 3 and 4. Okay, but instead of 4 someone actually writes just unknowingly 40, then your mu will going to be affected by it, right? But not in the case of median. Okay, and mode we actually just calculate the number of frequency. Okay, now we are actually not okay, yeah. So just remember, like all have different behavior according to the data. Okay, sometimes. So you just can't actually generalize it. And yes, Akshay, this is the bell curve. And if it is the if you people are, please let me know if you are people actually aware of the bell curve or not, because it will become much more interesting if I tell you the 95, 65, 95. Uh, yes, okay. 68, 95, 99.1. How many of you actually heard about this rule? Yeah, empirical formula. Yeah, exactly. So what we can tell, yeah, then this will be much more interesting. Okay. So what I can tell here, so how exactly the bell curve works. This is how it actually works. Like for the first deviation, we will say mu minus sigma. For the second one, mu plus minus, let's just say plus minus. Okay. Don't know, sir. Okay. I'm actually telling you right now. This is actually more to do with the probability density function. If you remember it, like 1 upon sigma root 2 pi, right? And you actually tend to put in the x values in it, and the moment actually spit it out, you tend to generate this sort of curve. Okay, like how this, okay, this. So you actually end up getting this curve. Like this is the actually normalized, curve. Like that is how we actually get. But if it is not, like I just told you right now, and Abhiram, if you actually remember like the histogram, okay, do you remember the histogram that I told you? How exactly it works? Like it works upon the frequency, right? What frequency that we are having on the y-axis, right? And then here, and then here, right? And then here. Okay. So what we can say is these our bell curve is nothing but the smooth version of our histogram, right? Basically, distribution is also telling us in what range and how many, right? Let's say you can literally tell with the PDF function or with the histogram, both. Maybe there will be some cases where you can tell better frequency with the PDF or better frequency with the histograms. The case is never be the case cannot be generic in any situations. Okay, but this is the PDF. If you really don't want to delve into the mathematics, then your PDF is nothing but the smooth version of your histogram. Okay, so now I hope you people actually get what exactly the PDF is, right? And how exactly, so this is the mean value. Okay, let's say now since you know the standard deviation, I can tell that from this part sigma to sigma, just remember my standard deviation, and 3 sigma. Okay, that's how actually it works. Okay, sir, is PDF always a bell curve? Yes, because it actually consists of normalized value. So PDF is always a bell curve, like not perfectly bell curve, but it will going to give you an intuition like this is a path. Okay, there will be like this sort of curve always. Okay, this or maybe this. Okay, or maybe sometimes this. It all will going to depend upon your standard deviation or variance, how exactly the spread of your data set is. All right, Akshat. So if the spread is not that much, spread what I actually mean here, how exactly your data, it can be also right skewed and left skewed also, na sir. It depends. Like for the right skewed, the data has to be heavy on the right side. If you remember, for the right skewed, what exactly it means. But okay, what exactly it means? This is the right skew. So this part of the data is not normalized, right? That is how actually it got skewed in the first place. So we tend to have the higher weights here, all right? Because as you actually move from left to right, you will going to see that x is going to increase. You just have to implement a simple math here, like right, x will going to increase. Okay, and the moment actually it starts to skews on the right or maybe on the left, or of course on the left it will going to decrease. But let's say you just mentioned that for the right it will going to increase from particular say from here. Okay, I don't know whatever the value. Let's say let's call it x. After the x1, you tend to see the higher weights that needs to be normalized, and this actually falls into data engineering and everything. But yeah, the thing that you can do here, you can normalize the data. Okay, and I hope like uh, the normalization of data is quite easy. You just have to perform like from 1, let's say 2 and 3. Okay, how exactly you can normalize it? You just have to divide the value divided by the sum of these all values. So 1 by 6, okay, and 2 by 6 and 3 by 6. Sir, normalization of data create error in data. Normalization of data? No, like I don't understand your question, Akshat. Okay, so let's actually finish it because we actually don't have like really less time right now. Let's actually finish it because we actually don't have that much topics either today. So I can literally take question for straight 15 minutes or 20 minutes. Okay, okay. So let's actually finish it. I'll be looking into the chat box for sure. And as I actually proceed to this, but proceed to end this notebook, but you can always drop your questions. Okay, I will go into answer. And now, actually coming back to the mean absolute deviation. So how exactly do you actually interpret it? Uh, you mean absolute deviation. Sorry. It is actually median absolute deviation, not mean. So what is the first pro? What is the first pros that you can actually tell? What is the first benefit of median absolute deviation? You can tell me. Can anyone tell me what will be the median absolute deviation? Deviation first pro will be like first pros. Anyone? Median absolute deviation. Yes, exactly. Very good. Reject of the outliers. It will not be going to hamper by the outliers. Okay. So why exactly we are choosing it right now? Because it is a good metric to actually deal with the outliers. Okay. So let's see. So mean absolute, I just wrote a simple program here. Okay. So pd.series, and this is again the pandas data frame. Okay. And then dot series, I'm calling the dot series here. And then array, then dot mad, median absolute deviation. All right. So it is actually an inbuilt function for median absolute deviation that is defined in the pandas library. Okay. So I'm calling it here right now. Okay. And let's see what actually it happens. So can anyone tell me in the chat box what exactly the force at 0.13 centimeter is telling us? Like what exactly it telling us? Let's say actually I write here the median absolute deviation will be xi minus xi for every ith value. Okay, xi. Just assume this is the xi and this is the median. Okay. So can anyone tell me what exactly must be happening here? Anyone? it is deviated with respect to the median. Absolutely, this is the simplest explanation, right? So how exactly we are calculating it? It's quite easy. First, we actually go through. First, we actually calculate the median of the array, a given array. All right. Then what we do, we have calculated the median. Then what we do, we just perform this calculation. Okay. So say you have like 2, 3, and 4. Okay. So you will going to reduce 2 by your median, 2 minus median, 3 minus median, 4 minus median. Since it's an absolute value, it can't be negative. Okay. So you will be going to have a new array. What it will be? It could be, let's say, your median actually that you actually found. It is right now 3 here. Okay. For 2, 3, 4. All right. So what I'm going to tell, like for 2 minus 3, it will be for 2 minus 3, it will be 1 since it is absolute value, then 0, then 1. These guys don't direct message me so other people can also, take benefit from your questions. Please put your questions in public mode so I can answer it for everybody. All right. Okay. So that's how you actually median absolute deviation going to work. So yeah, you can actually tell like every value for Setosa flower for petal length, your value is deviating for 0.13 centimeter. Like you can tell like all of the Setosa flower will going to have petal length around like same. Okay, because the deviation is not that much, 0.13. But for versicolor and virginica has the almost the same. So that is why we were having the problem, right? If you remember. Okay. Okay, so this was the median absolute deviation. Now comes the box plot and whisker plot. So why exactly it is useful and how exactly it actually stand out from the plots that we actually saw yesterday, like the PDF, and we also saw the histograms. So can anyone tell me from other than PDF and CDF? Other than PDF and CDF, of course, with the help of CDF, we can tell with what percentile value there will be the with what percentile value we can tell with the CDF function, right? But not in the case of histograms, right? So, is there any way that we can actually tell that what percentile of value actually lies within any given range? Can anyone tell me? Other than that, like PDF and CDF. Box plot. Yeah, exactly. That's what we will see. Yes, absolutely, box plot. Yeah, box plot for sure. So let's actually, make it much more somewhat intuitive by actually putting it on our Jamboard. Let me actually download it. Yeah, that's it. Where it is. Okay, so let's understand this box plot as well. So what exactly it is actually saying us, what exactly this box plot is telling us. So this middle part that you are seeing right now is the 50th percentile, right? Okay. And the above one is 75th, of course. And the lower one is what? 25th. So just by looking at it, I will come back to what is these are. Okay, these are basically the whiskers, and this is the outlier. Okay, I'm going to tell you how exactly it's going to work. Pardon my spelling here. Okay. So these are the whiskers. Okay. So can anyone tell me what will be the error rate for versicolor and virginica from this side here? Anyone can tell me what will be the error rate? This is actually the 25th percentile. Okay. And for versicolor and virginica, what is the error rate? We will be actually going to misinterpret with exactly. How many of you actually have understood that the error rate will be 25%? Everyone? Okay. No, sir. Okay, no. So let's say this is your 75th percentile. Okay, above that, this is your 75th percentile, and these are actually showing Q3 minus Q2. Yeah, exactly. Q3 minus Q2 is your 50 percentile range. Like that's where your 50% of the data lies. Okay, but not in this case. If you actually see below this, or if you actually see above this, so there is only exactly the 25th percentile where actually it starts. Okay, so I can tell less than 25 percentile, okay, of my data will going to misinterpret as versicolor. You can see it here, right? And this is exactly super useful information. Like you can, it is actually a great information if you actually making some sort of synopsis out of it, right? You can tell, you can just write it in the plain English that, sir, I didn't got what exactly is the error rate. Okay, error rate is something like, say, the versicolor and virginica. We are actually quite, solved with the setosa here. Okay. And now the problem that we have been facing so far is with the versicolor and virginica only, right? But with what percentage? You do remember, yeah, from the yesterday's session that we actually saw when we actually saw our distributed plots like these, but for the versicolor and virginica, what we saw, like this overlaps. But how much of this overlaps was happening, we couldn't tell, could we? But with the help of the box plot, we can tell that this 25%, there is 25% of error that is happening between versicolor and virginica, right? So that is the error rate. Got it? Okay. Okay. Everyone got it? How exactly actually I came up with the 25% here? Anyone have any question? Yes, sir. Okay. 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 So that's how we actually read our box plots. Quite easy, right? So this is actually our maximum value. This is actually the minimum value. And don't confuse, sir. This can be done for categorical data only. Uh, Not really. Like, let me actually tell you. Do you think, first of all, you can actually answer if pattern length is a categorical data or not? Just answer me in yes or no. Is pattern length is a categorical data? No, exactly. You just answered your own question. And we still plotted the box plot for a non-categorical data. So you have answered your own question. Got it, Akshay? I mean to ask on x-axis. Okay. So basically, okay, all right. Let me see a question again. This can be done for the category. No, this cannot be done only for the categorical data. I'm actually using, if you see the species here, like you, it should be done for the categorical data. Your question should be, it should be done for the categorical data. When you have actually like the classes, let's say you have 10 classes. Okay, so yeah, it should be. But if it is only can be done on the categorical data, then no, like you can literally create for the regression values. No, you cannot. But it should be or always should be done on the categorical data. Yes, for the categorical data, it should be in terms of box plots. Okay, and violin plot. So have okay, sir, got it. Mixed plots. Okay. So violin plot. All right. So have everybody got the what was the box plot was? All right. Okay. So now is the violin plot. Okay. And let's try to understand it. What exactly it is. Okay. So can anyone tell me what they are seeing right now? Like I would love to actually have your opinion in it. Like the way actually I interpret it is quite differently, but I would love to actually have your analysis as well. Like how many plots do you see here? Like, I'm giving you like for like 1 minute. Okay, just think and see how exactly these plots are working. Like build your own intuition. Can anyone tell me what is exactly going on here? Like here and here. Two plots I can see. Yes, which ones? Same like a box plot and bang on. Absolutely, bingo. It was spot on. Yeah, exactly. So if you just closely, just you just have to actually tilt your head off either on left side or right side. Then you will start to see a distribution plot as well. If you can see, we created the same distribution in our PDFs, right? If you remember. So box plot is quite, the violin plot is quite versatile in terms of box plot plus distributive plots. And again, these are the whiskers. Okay, let me actually again download it and put it there. Download one. Not a bad, not a good thing to do. Download one. There you go. Okay, let's try to understand this again. So this is again. So let's actually understand this plot. And this is again what it is median. Okay, and this is what median, then it will be 25th percentile, right? And what it will be 75th percentile, right? All right. Okay, this is 75th, this is median, and this is 25th percentile. And this part that you are seeing right here, okay, this part is nothing but your distribution, your PDF distribution. We actually saw it, right? So violin plots are great for actually visualizing both. You can literally interpret the box plot out of it as well, and violin and your PDFs as well. Okay, and now now you must be getting like how exactly you can read it. Like you can always look into this, right? And then this, right? So I believe now you must have got the. Can anyone tell me how many of you actually can read this plot? Anyone? Can you guys read this plot? It is similar to the PDF, like it is similar to the box plot if you actually remember. It's the thing that we have just covered just earlier, right? It is again the 25th percentile, it is again the 50th percentile, it is again the 70th percentile, right? And this is nothing but your distribution, right? Okay, so these were the violin plots, right? And do not forget to write your observations. Like I did not do it because um, I don't want to tell you people right now because I didn't do it because I didn't want to do it right now. But I since because I have went through this data set a lot. To be honest, like for like 5 or 10 times already. So it is quite embedded in my mind how exactly everything works. But if you are new to this data, like if I actually happen to work on, let's say, an image data, okay, so or any new data, let's say for X-ray data, so I will have to write my observations in every cell that I get, right? Otherwise I will be clueless after some time which feature was the useful or which even if you know which feature was the useful, then you will be having the problem with the metric. Okay, why it was useful, right? And how exactly it got affected, either with the mean or with the median or with the mode, or maybe what actually you needed to use as a metric. Like for the we use here median absolute deviation. Maybe in your case, while making a predictive model, you might use mean absolute deviation. Okay, so who knows? Okay, so always write your observations, right? So on text data, how we use these plots, is it useful to use on that or not? Okay, for the text and sequence data, there is a thing called NLP. Okay, and you tend to actually use embeddings there. You can use it, but really in small amount. Like you really don't use text there. You tend to use for entity recognition, which words were you actually were looking for if the data is there. But for the text classification type of predictive modeling, or if it is NLU, natural language understanding, you will be actually vectorizing your data most of the times. Okay, say you are actually writing in the next chart. Say you are writing how are you? Okay, so you literally can't, how exactly you can actually visualize it. You can just print it out, right? Using TF-IDF factorizer. Yes, of course, you can use TF-IDF factorizer, but when the data is really heavy, okay. And please, I tell you people, like, I know you people are quite curious about TF-IDF factorizer, or maybe like the back of words as well. But here people are from no machine learning background as well. Okay, I would love to actually take your questions because I have quite a soft spot for machine learning and both for software dev. Yes, using TF-IDF, you can always use it, but I always use BERT with the TensorFlow. I actually I heavily use TensorFlow my work, and yeah, it is, yeah, that's what I actually use. BERT actually seems to be work really well. Other than that, I use Hugging model as well, Hugging Face. Okay, we can actually talk about it in last like 15 minutes, since we don't have much left now. So yeah, so how many of you actually got this, like for the violent plot? Is there anyone who actually couldn't stand this, and and who actually want to ask me any questions about it? Anyone? No. Okay. And now comes the most interesting plot here. Like it is like my favorite plot. Not in terms of like, you can't really say favorite, but you have you actually tend to, the moment you actually start to do your own data visualization, you will find some shapes really fascinating. So this is the shape that I actually find really that actually fascinates me a lot. Okay, because the way it get generated, it is really good. Okay, so how many of you actually, before actually diving into this multivariate probability density contour, so how many of you actually have heard about the parabolas, right? So not for the, let's say parabolas. I have a f of x is equals to x square minus 1, right? This is our parabola. Okay, and how exactly it is going to protect minus 1? Okay, so it will be somewhat like this, right? Sorry, like this. Yes. So this will be minus 1, right? This will be minus 1. So how many inputs, how many variables you can see here? Can anyone tell me? Like if it is y, how many input variables you can see here? Anyone can tell me from mathematical background? One, exactly. This is the only x. Yes. And can anyone tell me, if I say x square plus y square minus 1, okay, is equals to f of x comma y. Now how many do we have? How many input variables do we have right now? Now we can see that we have x and y, right? So it means we have two variables, two input variables. Okay. But can anyone tell me how many input variables do we have in this case? We have X and Y. But till now, we actually calculated our density plot only on one. If you remember, with the histogram, right? But what about the two? What about the two? What we say? Variables like petal length and petal width. How exactly you can do it? There comes our contours. So how exactly your contour works? Let me tell you. Let's see. Let's just imagine you have XYZ plane. Okay. Let's imagine this is your Y. This is your say Z, and this is your X. Can you explain this once again? Yeah, I'm explaining it. Don't worry. And 3D like. And 3D like no sir. What? Okay. First, actually, let me just. This is your. Let's say this is the function that you get. Okay. Okay. That actually takes two variables, X and Y, and Z as well. Okay. So just try to imagine it in 3D. Like I am constrained to 2D here and only. But how exactly we can actually plot out the contours out of it? So as you remember, can anyone tell me this and this? So is there any relation to the spread? Like if you can see the spread for this one is more than the this one, right? Right? Okay. So can anyone tell me if I slice it here and I slice it here, which slice will going to have a bigger circumference, like bigger surface? I don't know what we will going to call it. So I'm calling it a pharynx. Like I don't know because it is not a circle for sure. If you actually, let's say call it a watermelon, and if you actually just slice it, so the under surface will be a circumference. Like it is a circular. It will be a circular, right? So which shape will going to have a bigger one, like a spreaded one? I believe this one, right? Rather than this one. So can I actually plot it out somehow like this, or like I can tell down one. So can you tell which one must have actually got sliced up? Like I can tell this slice actually belongs to this, right? Just hold on, hold on here, okay? And this slice actually belongs to this, right? So let's again actually make it much more intuitive and make it understand. Let's slice it. Okay. So the moment you're going to slice it, and since it was on the 3D plane that you can't actually, visualize on a 2D plane, to actually make it on 3D, to actually make it on, sorry, 2D, you just have to slice it. And the plot that you will going to get on XY plane only will be somewhat like this. Let's assume that this is the, this one I am actually taking first. Okay. So first one will be the smaller. The second one will be the much more smaller. Then, right, right. So that's how our contour actually forms. This is nothing but a contour. And the more it has the central tendency, the more number of the elements or the more number of the data points it will going to withhold itself in itself. Okay. So the farther it gets away from the center tendency, the fewer the point it will going to have. All right. So how many of you actually got the contour plots? Is there anyone who actually couldn't understand? Sir, can you please again from start? I didn't got it exactly. Okay, sure. Say, so you do understand this 3D plot. Akshat, tell me, you do understand this 3D plot? Yes, sir. Okay. So now let's say I am actually slicing it up from this. Just understand this. Let's say you have a watermelon in your house, and it is actually kept in a 3D room. Okay, and it is actually kept on its vertical position. Now you start to slice it with your knife. Sir, 3D plots we got using PDF, right? No, 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 no. You are getting it wrong. Like So, sir, 3D plots, we got to use PDF. PDF has nothing to do with the 3D plots. Is there anyone who is having like the same thing that 3D plots had anything to do with the PDF? No, it is not. PDF has nothing to do with the 3D plots. PDF could be plotted on the 3D plots for sure. Like this is a PDF, but we can also plot our PDF. We saw it yesterday on the 2D as well. So above 3D, 3D feature means 3D plots, right? 3 dimension means 3D plot. First of all, okay, yes. So for according to you, Chira, features mean 3D plot. It is correct. Yes. So about 3D plot, can you explain me once again? Yes, sure, Akshat. Please actually just bear with me this time and just try to imagine with me because I really can't do it on the 2D plane with 3D action, right? So just try to imagine. Let's say this is actually a bell curve on a 3D plot. Okay. And again, I am actually emphasizing here, like I am again telling you, it is not necessary that you can only plot the PDF on 3D plot, right? We saw it yesterday. We literally plotted it out on 2D plane as well, right? So don't get confused with it. Like we can only plot it on only on the 3D, all right? So let's try to actually see that we are slicing it up. Okay, the moment you actually slice the first part, what you will get somewhat like this. Okay, and just try to use your imagination and just see that how exactly the lower part of it will going to look like. Okay, and usually do you really think that x square plus y square will going to look like a melon? I don't think so. I just gave you an example here, like just to actually make it metaphorically, sound. Okay, so we keep slices one upon other per size. No, no, we don't. No, we don't. What we do here instead, we actually take it and we actually squash it down. Okay, let's say you actually got these slices. Sorry, this was actually big. So this slice, then let's say after the slice, after the cut through, then this slice, then the bigger one. Okay, so what we do, let's actually imagine yourself pushing it down with your palm, right? The moment you are going to push it down, it will going to adjust in this, and the both will going to adjust in this. Okay, so it is actually not kept upon in each other, but rather actually it is being shown on 2D plane, on XY plane, right? Got it now, everyone? Okay, sure. Yeah, okay. So how exactly we can read it? Okay, so do you remember what I told you? Like, sir, please pin the attendance. Oh, sure. Where it is? Let me actually finish it. I'm actually just I'm totally done with my.
Sir, I'll give the attendance.
Yeah, sure. Okay, thank you. So now, how many of you can tell me? Uh, how many of you can actually read this now? I just told you the center tendency tend to have more number of features rather than the tendency that actually the layers or these contours that actually gets farther and farther away from the central value, right? So in this region we will be having the most features, and then this region we will be having the most features, and again we are seeing the collapse here, and on and now how many of you can actually see it, like there are like we do you remember, like we actually came up with a conclusion like only 25% of the error rate, and you can actually see it here as well, like not entirely, but there is a small chunk of the data from the versicolor and virginica which is getting overlapped with each other, right? So that is how you actually read a contour, all right? And these are nothing but your PDFs, right, that we actually saw earlier or yesterday. Okay, so this was your multivariate probability density and contour. Okay, so multivariate probability density because we have three variables here or three classes here to be precise, this one and this one. Okay, and each class has four features: petal width, sepal and sepal width. So we are done with the multivariate and everything, and the course overview or everything that we actually had in our minds. Like, we are done with the course right now. The data prep with the ED documentation, I'm going to now tell you. Okay. So summarizing plots, univariate, bivariate, and multivariate. This is the, let me actually give you some sort of conclusion. So this is my last conclusion. So from all the analysis, I can tell that petal length and petal width are the most useful features, right? Whereas we are able to tell quite clearly about certain such species as well, but there were so many overlaps between versicolor and virginica. But instead of so many now, you can actually make it much more better. Like, instead of so many, I can tell there is around 25% error or overlaps, 25% data overlap. So it is already done here. Data overlaps between versicolor and virginica. So this is my final conclusion, right? And you do realize how exactly we actually came up with 25% here, right? Okay, so we are done with this. And now exactly what I want you guys to do. So this is this even if you actually uh, I actually assign some assignment. So this is the assignment that I am going to tell you. I am going to assign you to people. So our minded aside. So everything that we have actually saw till now, all right, everything that we have saw till now, please go through this data set, okay, and implement it on this data set. Like, it is only 3.3 kb, won't be that much of a big deal, and just download it. And uh, instead of you, okay, instead of species of flowers like setosa, versicolor, and virginica, we have here survival status. Okay, try to understand this. You can see the count here, 224 and 81 for 2, count for 1 is 224. Try to make it much more intuitive according to you. Sure, I'm sending you the link. There you go. Okay, this is the data set that you actually, whatever actually I have taught you, told you, whatever we have actually covered till now, please use that knowledge and make a use case study out of this data. This is quite easy data set again, that will not going to intimidate you. Sir, I have seen a box plot where 75% line isn't there. What does that exactly means? So, Akshat, please tell me where. Like, I have never encountered such lines. Like, it is not possible either. But please tell me if you have seen it. I'm sending you as a minute. Sure, do it. Anyone has any questions? Sir, I want to say that two words. Yeah, sure. Okay, so there is nothing to get offensive, student. Okay, you can literally ask me. All right, so I can't understand anything what I got. You would have actually told me. I actually asked you people like, how many of you actually got it? Okay, and I again and again told you how exactly. Okay, confused. So student, I believe the name is only student, so I'll be referring as student. So you do realize this is the what it is. This is the distribution plot, right? Density plot, sorry. Right. First, actually, Akshat, please let me actually, solve this question first. Okay. So please, student, please let me know if you have understood it or not. Okay. So first of all, tell me, can you see two types of plot here? First is the density plot, and second is the box plot here. Can you see it? Please tell me. Yes, sir. Okay. And now, can you see these values? Do you understand, do you see that this dot value, this white dot value, can you see? Okay. So this dot value is the median, right? What it actually means? What it actually means that 50% of my data, this is data analysis. You really need to write a lot here. Okay. So 50% of my data will be going to this much, like for what it is 4.4. So 50% of my data will going to have for the versicolor less than 4.4 centimeter of petal length. Understand that statement or not? Okay. So you can also again make intuition out of this 75 as well. Yes or no? Please tell me. Yes. Okay. So now, do you understand the distribution plot, sorry, density plot that we actually covered yesterday? This one? Yes. Okay. So just tilt your head either on left side or either on right side, and the moment you actually see it, okay. So this is the mean. Sorry, I can't like there are. Let me actually erase it. So you can see what is the mean value here, right? So this is nothing but your combination of box and distribute your density function. Okay, all right. So now you can tell that just by looking at this plot, this is just by looking at this plot, I can tell that my mean value for Satosa is around 1.5. Like it is 1.4 that we actually calculated. Okay, say 1.4 because we already knew it. Okay, but at first glance, you will say it is around 1.5. Right. So now you write a statement. My Satosa flowers having a petal length of mean or the average petal length is 1.4 centimeter. So that's how we are actually making the observations. And out of this, I can tell 75% of my data is having less than 1 point, whatever it is value, 1.4 or 1.7. And we actually saw it when we actually saw percentile values. Let's see here. Where it is, where it is. For Satosa, okay. So this was like 0, 25, 75, right? So for Satosa, we can say 1.4, right? And what we are getting here around 1.4 or something. 75. Okay. So that's how you actually can read it. Now you got it? Oh, no issues. What was your question again, Akshat? Abhiram is asking, assignment is that now what all you done that should do for others example. Yes, like whatever actually I have covered till now, Abhiram, whatever the methods, whatever the observations that I wrote, whatever the math or libraries that I used, sorry, you need to actually reuse them and make your own observations on this Haberman survivals data. Okay. And the best thing that you can do with this, like just take it as a case study and make a blog out of it. Like just always write blogs. When you actually want to learn something new, or maybe when you actually want to understand something new, just write about it. Okay. Okay. So the moment actually you actually are done with your own observations, just write a blog about it on Medium. Okay. That way, you will going to have a better understanding what exactly you did and why exactly you did. Right? Okay. So can I share? Uh, I don't know if it is allowed. Can you actually let me actually write your question again, Akshay? I am not able to send it back. Why don't you write your question again? You said that there is a 75. If we don't see a 75% tile line in box plot, right? Like it will be there. Like I don't see there will be not like it won't be visualized. I mean, uh, but I haven't actually encountered with such. I mostly actually work with the vision data. Like I work in the computer vision field mostly. So yeah, it is. It could be. Sir, my question was I have seen 75 percentile line in box. Basically, it was middle line and 75 the same. So you are telling me 50 mean. So you are telling me 50th percentile and 75th percentile were the same. Okay, so it doesn't actually sounds really mm, logical to me. Sorry, like how exactly it is possible? Can you actually give me any example of data? Just tell me the data. How exactly it is possible? Even if you take any sort of array, sorry, array, not array, sequence of data. Let's say whatever the data you take, there will be the chances. Why don't you use the imager or okay? Let me actually wait a minute. Send me here right now. Okay. Yes, exactly. That will be the only possibility. The whole sequence the same value. Yes. In that case, everything will be the same. Then the data is corrupted. I believe. Like you just can't have duplicate values. So there is a thing like TF dot duplicates. But let me see. You said Akshat. Yeah. By when we should assign it? Like in next 3 days to be max. You can submit it. Okay, send it. Okay. Where? I don't see any. On mail, I don't see it. Actually, there were very less data and it was repeating there for PC middle 75 4%. Yeah, that is the case. Akshay, okay, that actually just okay. This is the data that you are all right. All right. So the problem here with the data, you people can see it right now. So the problem here with the data, okay, not with the like as the Akshay actually mentioned, the values could be actually found are the could be the duplicates, a lot of duplicates, right? In that case, we could have a 75th and 50th percentile on the same level. Okay, so yeah, that could be the case. So the problem on yes, always remember when you don't see anything, logical with your graphs, always check your data instead of your parameters. There will be the chances when you will see that when you will be seeing like okay the data is may be working right, but people used to run towards the parameters. Sometimes when you actually plot something out or something to do with the model, they actually run towards the logical side of the algorithm. But 90% of the time when you actually are trying to improve your accuracy of a model, or even if you are trying to make predictions or running an inference, and if you actually come across any errors, or if you run into any errors, just check your data always, always, because the problem most of the time with the is data. It could be the problem like it has some sort of unwanted values, the data could not be normalized, there could be a number of factors, like the metric that you chose were wrong, like, and the data actually needed something else. So yeah, so always run towards your data, what how exactly you were actually handling it. All right. So yeah, any questions? I can take questions for like next. Be it for machine learning, be it for deep learning, even be it for software dev, like web development and anything. Anyone have any questions? Can you share the roadmap for data science? Yeah, absolutely I can. Like the thing that we just covered in 3 days usually is not the complete thing. I just have to be, honesty, because you have seen like sometimes I really have to skip something, like I couldn't complete with you guys probability density function. Like this is my the most favorite feature to actually discuss with the students, and and people tend to have lower level of knowledge about the mathematical background. Like people have actually made it like okay, we can just use a library, we can just use dot fit method, or we can just run some sort of library installations and we are good to go, right? So always have a good grasp over statistics, probability and math. I can actually share something with you guys. Wait a minute. That I actually prefer. It is totally math savvy, like who actually like to do more and more math. This is the best thing that can, I actually refer to it. I don't use any machine learning books. I don't use anything. So if you are saying for the data science roadmap, this is the best. Like you cannot get any better at this. Like, okay, this is the best, right? And whenever you actually look up to something, like when you want to actually see, when you actually want to see where you might have gone wrong and want to make some sort of optimization, this is the book actually I always refer to. It is the best book. And other than that, try to better your statistics. So I can actually refer you a stat channel as well. Okay, this is the statistics that I always refer to. So yeah, so the statistics that I actually gave you, the link, and the upper thing, like for the data science, it will be good to go for the machine learning to understand it, not for the coding part. It is totally math based, and I have a really, really, soft corner for math. Like I really love to explain it to people, like who I have actually mentored in the past. And yeah, math is something that you can actually never ignore in terms of data science. So whoever is saying that you don't need math, just don't listen to that people. Just don't listen to those people. All right, they are not making any sense. Like you will be going to need math for any data science task, be it for analysis, like we saw in pair plots. If you have no idea about the combinations, like you don't know about how exactly the permutation and combinations work, then you cannot come up with like NC2. Like you don't even know how exactly these pair plots are being plotted, right? So always have a good math understanding. Always, even if you are not from math background, there is Khan Academy. There are several free open source tutorials, like you can always look up to. So, sir, I needed your suggestion on topic. I was working on IPL data, where they gave us ball by ball data, and we need to predict 6 over scores. Which model can be used? All right. I really have to look into the data first. So, what we need to predict? Uh, six balls. I couldn't understand what is the 6 over score, because I don't actually follow the cricket. I don't watch cricket. Okay. So the data was venue, batsman, bowler, striker, non striker. So I really have to look into the data set first. Okay. So whoever actually haven't actually please connect me with on LinkedIn. Connect me. I just gave you my email address. Please use it and reach out to me in any case if someone want any sort of suggestion. Okay. Yeah. You people can actually reach out to me there as well. And on my LinkedIn as well, I have dropped it. And yeah. And yeah, that is it. Any other question? Any it is okay. Any other question? Like I always use random forest for my personal preferences because it always most of the time it works well because people actually tend to say that machine learning models are black boxes, you don't know until you use them. So it is not quite correct. If you are aware of your domain, let's say I have worked with a data set RNSA. Okay, basically it's a radiologist data set where I actually have to tell from the X-ray that what sort of hemorrhage you are dealing with. Like if it was epidural, subdural, epidural. Okay, there were like 6 or 4, I don't remember. So I worked on the data for straight 5 or 3 months, and I got really good uh, knowledge about the brain parts. I really had like I still do have the knowledge about the cranial nerves, all the four lobes, occipital lobe, and everything. Just because of the data I needed to understand, because I had to see where the clogs were forming. Basically, when the clogs actually forms in your brain part, any brain part, that's where you actually gets diagnosed with the hemorrhage. All right. So yeah, you need to have a good understanding about the domain before you actually tackle it. Like for any data, just try to get the domain knowledge, even on the superficial level. Plus, but please do it, right? And Umang, could you please share the attendance stick as well? Like with me, the actually I have to fill it.
Yes, sir. I'm sharing the attendance.
Anyone, any questions? Sir, send your notebook. Yeah, sure, I will. I hope you people actually learned something new or maybe something useful throughout these 3 days. All right. This was for the day 2, I think. Not the attendance. But sorry, I actually may have actually misspoke. I actually meant like the thing that we actually I have to fill. Okay. After the training attendance, I believe that we actually you can wish about the PGP data science. So how could I prepare for finance domains, capital market? Is there any specific important? It is quite again like you are the thing that you are asking me right now is the forecasting, right? The forecasting domain. And you need to actually prepare a lot. Like there is A5, M5. Like I have actually worked with a data set called M5 sales or something on Kaggle. Like it has been like 1 or 2 years or so. I don't remember correctly. So try to actually get your hands on dirty on the finance data as much as possible. The the domain that you actually wants to get in is the forecasting, like forecast. Data analyst profile also required maths. Absolutely, it does. Like you have seen it. Like, uh, did you see in any observation where I did not use math? I did, right? Like there are no chances that I won't, right? Okay. So if you guys actually like these 3 sessions, like you can always go for the mm, wait a minute. You can always go for the PGP data science course that actually Let's Upgrade is providing. So you have seen like how exactly we work. we actually like to delve into more into detail rather than just giving you the superficial knowledge. Okay, so go for it as well. And sir, I am planning for data analyst. Is Python relation software are enough? Python, okay, Python is good, like okay, and visualization softwares like Matplotlib, Cbon. Yeah, it is good, but you need to make your own case studies. Like just knowing them will not going to get you a job, right? Take any data and make something out of it. Okay, just write your observations out loud. Like make a blog out of it. Just explain it on YouTube. Okay, write it on Kaggle. Just do it. You really need to make your own observations. Assignment is important. Absolutely, it is important, Sushil, because otherwise you won't get a good idea of how exactly things work. Okay, in the first place, maybe you are getting it right now because I am with you. I am here to actually help you out. But when you are alone, believe me, when you are alone and when you are coding alone, the scenarios actually gets changed, because when you are seeing someone who is coding and when you actually happen to code yourself, the things the both of these are totally different with each other. So please get your hands dirty as soon as possible. Assignment is important in a nutshell. Anyone else? Any questions? Anyone? Okay, so I'm stopping my screen sharing now. Is there anyone who actually wants to ask any question regarding to anything, like be it for software dev or data science?
Hello, sir.
Hello.
Hello.
Okay, I have a chat again. Sir, how we use SQL in data analysis? Well, we use it like for the pandas, the memory efficiency is not that good when you are actually dealing with the millions of data set. So yeah, you actually use SQL queries a lot when you are fetching the data from the data frame, like from the dot SQL files. Okay, so SQL will going to be useful when you are extracting the data by groups or by whatever the methods that you can use. You can always use those methods with the pandas as well, but the SQL tends to have the optimized way, right? Okay, info about the project in PGP program. You can actually always reach out to the Let's Upgrade, and Hemu is asking, sir, could you please explain what to do on daily basis for practice? Just practice. Hemu, just practice. Like for my personal experience, when I was in college, in to be honest, I actually got serious about coding when I was in my around like initial days of third year. Okay, so I used to do like I used to solve those Python questions a lot, right? So when I'm done with those Python questions, from like I have solved those questions like 5 times while getting platinum range. Like when I'm done once with all of those questions, I will make another account just to actually get a good grasp over it. Like that is how exactly you actually build intuition for programming. Okay, so just practice as much as you can. All right. And what actually do we need to explain in assignment? You need to explain in assignment whatever you are making a plot about. Let's say you made a scatter plot, right? Then just write about the scatter plot. When you are making a PDF, just write about it, just in your own language, what you are getting out of it. All right. And I think these sessions are recorded. All right. So I believe these sessions are recorded, right? Because I always acknowledge to the accept button whenever someone.
Yes, sir, these sessions are available on the Let's Upgrade LMS portal, and all the registered students can watch the session as much as time on the Let's Upgrade website. in my program section, they'll get data visualization essentials program, and they can watch all the 3 sessions there again.
Okay. Okay. So yeah, Neha, just practice or write your own thoughts. That's what I can actually tell you right now. Okay. From where should I get practice questions? Use HackerRank, and for the theory purposes, use Geek for Geeks. That is the best and to the point. But for the questions, use HackerRank's Python section. Go through it. Even if you are done once, just do it twice until you actually get it everything at once. Like that is how I actually used to do it in my college days. Okay, so that is how I actually good became good at programming in first place. So when you actually good at programming in either of those languages, be it Python, be it any language, JavaScript, you won't be having any problem adapting to new language either. Okay. So, is there any exam? Please reach out to Let's Upgrade in that case. All plots should be done in assignments. Yes, all plots should be done, Abhiram. Which domain questions asked most in interview? Well, it depends upon the company you are actually getting into, right? Let's say for PayU or uh, it all depends on the startup type or the company type. If you are actually being interviewed at a computer vision company, just get ready to be asked computer vision questions. What is the assignment deadline? You need to complete in 3 days. How to access this recording? You can always reach out to the Let's Upgrade in that case. So for visualization, we have Tableau or other platform. Why we use Matplotlib? Tableau actually runs on its own. Like everyone has their own preferences. I am more of a programming oriented guy, so that is why I actually use Matplotlib. Them can we can't see the notebook. Means difference between them. Okay, difference between them again. I just told you like I prefer programming more. So thanks a lot. Yes, there will be. Okay, yeah, yeah. Just Shiva just gave you the answer. Till when we okay any hacker rank or hacker earth rank rank is not helpful. Just don't do it for rank. If you really want to get good at something, don't do it for like ranks or something like you are doing it for rank or something. Just don't do it. If you really want to do it, then do it. Otherwise, don't. That's what I can actually tell. If you really want to get good at programming, then do programming. Just don't think about the ranks, right? Tell about these. You can Vijay, you can reach out to the Let's Upgrade for the certificate. All right. So this was it, guys. I had a fun. Like I really had fun teaching you people. Like I always like to teach, and I really had good time with you. You were patient. Okay. So thank you so much for joining in here and best of luck. All right. Is it necessary to be excellent at wait 1 second, coding? Yes, it is. Like not excellent, but you need to able to make your good intuition. Like you need to develop a programmer's thinking pattern. Like whatever your native language is, you can think better in your Hindi, maybe in Tamil, maybe in Telugu, Malayalam, any language. I can think better in Hindi because my native language is Hindi, right? So the same goes for the programming as well. So when you actually want to understand something in some like whatever we do in terms of programming, we are literally communicating with the computer. That's how exactly the programs work. And with the algorithms, of course, we perform set of instructions. That is another thing to discuss. But yes, of course, you really need to have a habit of developing the thinking pattern in terms of coding, and that coding language could be anything that you are actually comfortable with. Okay, right, Emu? Okay, thank you, thank you. Okay, there will be an MCQ examination. Yeah, there will be. Tell about certification. Yeah, you can always reach out to the certification for the how many hours should we spend on codings. Well, it again totally boils down to you guys. Like, if you are doing it for 2 hours a day, 2 hours a day is suffice, like more than suffice. And if you are a student, then do it as much as you can. Okay, just do it as much as you can till we grasp it. Yes, of course. So yeah, okay. So that was it. And anything else like Umang, is there anything else that I need to done before leaving this session?
Yes, sir. I am sending it in private chat.
Yeah, sure.
Thank you.
Please don't do assignment for certification. Please don't. Okay. Do assignment for your own clarifications about the concepts. And it is actually a general thing, and general, should be a mindset. If you are doing something and if you are learning something for only for the certifications, then your knowledge will going to be, you will going to have a limited knowledge, right? You can never think out of the box in that domain. You may reach out to you may actually get a job, but you will honestly you will not get good at that job, right? Like, maybe you get the job for like for the data analyst position, but it won't be that efficient. So please don't do anything for the certification. Do for the learning purposes. If you really want to learn something, then do it. Okay, just not for the certification. So what other sites would you recommend for getting data sets? You can always use UCL data set. Okay, and Kaggle is always my favorite. Yes, of course. Yeah, this is enough actually. UCL. Other than that, I actually can recommend you UCL. Okay. Sir, I was watching on YouTube as I joined. Can you please explain what are the whiskers and box plot? Okay, okay. Those whiskers are exactly the maximum value and the lowest minimum value that actually exactly is being showed up there. Okay, right. Uh, all right. So that is it, guys. Thank you for joining in. Thank you so much for listening to me. Okay. Sorry, like which size of data set can be considered for the project. It again boils down to your needs. Like you can literally make a good project out of like 10 MB as well. You can literally make out of 3 KB as well. There's no, number for it. Right? All right. Bye, everyone. Thank you so much.
Thank you so much, sir.